Here's question 4 on functions, and part I or part A, you've got to find the values of A and B, and we know what fx is, and gx has got a's and b's in, which we've got to find out. But we do know what the composite function fg equals. Okay, so when we substitute gx into the x in fx, we know we're going to end up with this. So in other words, when we do 2ax squared plus b plus 3, we know we get 6x squared minus 21. So if we expand that bracket, we get 2ax squared plus 2b plus 3 equals 6x squared minus 21. So looking at this equation now, you can see that the coefficients have to match. So the coefficients of x squared are there. So we know that 2a must equal 6. In other words, we know a equals 3. And we also know that the constants must match 2, must be equal. So we know that 2b plus 3 must equal minus 21. 2b plus 3 equals minus 21. And therefore we get b is minus 12. So that's the answer to part 1. Looking at part 2 now, you've got to find the greatest possible value of q. So the greatest possible value of q, well, if we take a look at fx is only defined when x is greater than or equal to 0. So therefore, when we sub in gx into fx, gx must be positive. So gx must be greater than or equal to 0. Otherwise, we wouldn't fit the domain for fx. So therefore, if gx must be positive, we just worked out what a and b are. So gx equals 3x squared minus 12. If we know that must be positive, then we get that. And now we've got to solve this inequality. So x squared divided by 3 here, we get this. So you can see it might be a good idea to sketch a graph that would look like this, minus 2 and plus 2. So where is this graph greater than 0? Well, it's greater than 0 here or here. Now, the question is saying what's the maximum value of q? Now, we've got to say that the maximum value of q is minus 2. Maximum value of q is minus 2, because if q was, let's say we thought the maximum value of q was plus 2, so if we said the maximum value of q is plus 2, then what we would be saying is that that means that x could be any value less than or equal to plus 2. But that isn't true. X can't be any value less than or equal to plus 2, because if that was true, then x could equal any of these values, but it can't, because we need gx to be positive. So we can't say that q is plus 2 q must be -2. So this is the answer to part 2. Maximum value of q is -2. For part 3, we now know that q is -3. And we've got to find the range of fg. The range of any function is just the possible y values you can have if you were to sketch the graph. So if we just do a rough sketch, let's see what this graph would look like. So let's just do a quick sketch. It's 6x squared, so it's going to get big quite quickly. So let's do it like this. Okay, and we'll put -3 roughly around there. Now, since it's only defined for x less than -3, we can actually just scrap all of this. None of this fits the domain, so none of that is any good. So what we need to do is find this value here, this y value. So if we sub in -3 into this, so let's just put -3 into fg. Struggling here. So what do we get when we put -3 in? We're gonna get 6 times -3 squared -21, and 6 times 9 -21, which is 33. So that value there is 33, which means if you're looking at the possible y values, the possible y values are any value greater than or equal to 33. So therefore the range of fx is y is greater than or equal to 33. Last part of the question, we've now got to find an expression for the inverse function. So part 4. So let's just let y equal the original function, which is 6x squared -21. Swap the x's and the y's round, so then x equals 6x squared, sorry, 6y squared -21, and rearrange to get y on its own, so that'd be x plus 21 over 6 equals y squared. So then just y is going to equal the square root of that, plus or minus the square root of x plus 21 over 6. And so therefore the inverse fg minus 1 of x is that, plus or minus x plus 21 over 6, all square rooted. And the very last bit of this question, it says find the domain. Well, the domain of the inverse function is going to equal the range of the original function, and we've already worked out the range of fg in the previous question, so we know the range of fg is this, and so therefore the domain of the inverse function is the same. So the domain of fg to the -1 of x is greater than or equal to 33.